Hi everyone, welcome to another STEM tutorial. In this video, we'll look at deriving the Newton's method from the Taylor series. We hope to provide you with a clear step-by-step explanation to help you follow along. So as you can recall, in our last video, we had looked at applying the Newton's method to find our zeros for this function down here below. So to find our f of x equals 0. And we had described these 4 steps. So if you don't recall these 4 steps, please feel free to click on the link to this video. In today's video, we'll be focusing on this equation here from step 2. So we'll be looking at how do we derive this equation. And hopefully this simple explanation that we're about to show you will help you better understand the Newton's method so that there's no need to memorize very much. So to start the derivation, we have to recall the definition of the Taylor series here. So remember, the Taylor series is just a representation of a function about a reference point. And so to start and derive this equation here, what we're going to do is we're going to look at the Taylor series only about the first 2 terms. So we're going to truncate the second term. And so to help simplify the Taylor series and help you understand what's going on, if we rearrange this portion of the equation here, you'll see that we essentially have the definition of a slope. So I'll just write this down. So here you'll see if we rearrange this function here for our change in our function with respect to x1, we get this definition here. And if we look at this closely, this is really just the definition of our first derivative, or our slope, where we have our rise, so our increase in our y, compared to our change in our x. So if you recall what we had discussed on the Newton method in our previous video, you'll remember that for the Newton method, we essentially draw tangents to look at where f of x equals 0. So referring to this plot down here below, if we choose a starting value, so for instance x equals 3, what we essentially do is we draw tangents here to this line and look at where do I intersect with my f of x or y equals 0. Then we establish this x value as our x2, calculate our f of x, and do the same thing again. So we again draw a tangent to this line and look at where do I intersect with my f of x equals 0, so here. And we continue this procedure up until we are very close to our f of x equals 0. And so when we look at our Taylor series, all we're going to do now is say that our f of x2 value has to equal 0, so that we intersect here with this line and establish our x2. So I'll just write down these steps. So what I've done is I've again written this equation above, so for only the first 2 terms. I've written it down here below. And what we'll do is we'll say that our f of x2 has to equal 0, because of course this follows the concept of our Newton's method. And so if we now arrange for our x2, which we want to solve, we want to know where does this tangent intersect with our x2, we'll get the following equation. So I'll just write down the steps again. Rearrange for x2. So we see here we're rearranging. Now we're running out of room, so we're going to continue writing up here. So then we see if we write it differently to get this form, we'll just write down x2 equals x1 minus f of x1 over f prime x1. And now if we generalize this statement here so that we have the I plus 1 in I nomenclature. So here the 2 representing I plus 1 and the 1 representing I. Then we would write down x of I plus 1 equals x of I minus f x of I all over f prime x of I. So then you'll see that this equation here matches the equation that we're using as part of our Newton's method. So this wraps up our Newton's derivation tutorial. If you enjoyed this video, please hit like and subscribe below. If you have any questions, please feel free to leave them in the comments section below, and we'll do our best to get back to you. And for more exercises and quizzes, check out our website, stem-tutorials.com. Finally, if you would like to learn about numerical methods, please check out our Numerical Methods YouTube playlist. Thanks for watching and have an awesome day.